All right, condensing and expanding logs is your next topic. There are three basic rules with condensing and expanding logs. Do not make this more difficult than it is. If we have log of x plus log of y, they have to have the same exact base, so we'll just call the base n. Then that means this is equivalent to log base n, same exact base, of x times y. So in the world of logs, if you're adding them and they have the same base, then that means we can multiply x and y together to get their product. All right? So log base n of x minus log base n of y. Well, if adding means multiply, what do you think subtracting means? Subtracting means divide, so log base n of x divided by y. Okay, and then if there's a number down in front of the log, so number down in front of the log base n of x, then what we do with this number is we bring it up top. So log base n of x raised to that number. So let me give you a couple of problems what this could end up looking like. Condensing means we're going to make a larger problem smaller. So let's say we have log base 3 of 4 plus log base 3 of x. Okay, we'll look up and see which property that we're using here. We have logs with the same bases and we're adding. So logs with the same bases and we're adding means we multiply. So this becomes log base 3 of 4x. Okay, let's say we have 2 log base 9 of x minus 3 log base 9 of y. Two things going on in this equation here, okay? You have the numbers down in front, and we have a subtraction. Well, let's deal with the numbers down in front first. Numbers down in front become exponents. So this is log base 9 of x squared minus log base 9 of y cubed, okay? So the numbers down in front simply moved up, became exponents. Now subtracting means divide. This is going to go on top. So the log base 9 stays, and then we just have x squared over y cubed, and that would be your solution. Okay, one tricky thing that you kind of got to get a hold of here is if you have like 1/3 log base, a log of x, okay, which can also be rewritten as, well, let's just say we have a problem that looks like that, okay. You might see it like that as well. Well, this is an exponent of 1/3. An exponent of 1/3 means you end up with a square root or a radical answer. The adding means we're going to multiply. So this is log of xy, and it's actually the cube root, okay? If it was 2 down here, it'd be a square root. If it was 4 down here, it'd be a 4th root. 5 would be a 5th root, so on and so forth. So anytime we're condensing them, you take a larger problem, you make it smaller. Adding means to multiply. Subtracting means to divide. Numbers down in front, take them up as exponents. Expanding, all the same rules. Okay, so let's say we have log of xy to the 3rd. Okay, now we're going to write it out long ways. Well, there's two things happening here. We're multiplying them together, okay, and then this one has an exponent. So let's just undo the multiplication. Well, they were multiplied, so now we can add. And now the number up top is going to go down in front. And that's the expanded form of that, okay? So we're just going backwards whenever we're expanding these things. One thing to keep in mind is if you have a scenario, I don't know, that might look like that, I would highly suggest you fix this issue first. So this would be like log base 2 of x to the 6th over y to the 3rd. Okay, and now you can deal with it because power raised to a power, we multiply. Now we have this case, division. Division means we're going to subtract. So we'll have log base 2 of x to the 6th minus log base 2 of y to the 3rd. Notice the top thing goes first, the bottom thing goes second. Numbers up top. Well, numbers up top mean you move them down in front. So 6 log base 2 of x minus 3 log base 2 of y. And then that is the expanded version of that. Okay, so hopefully you have all the notes on condensing and expanding. If you missed that first piece or didn't write it down for whatever reason, there it is one more time for you, all the different properties for condensing and expanding logs.